Hey guys, so I'm throwing away all the segments that I did up to this point today, and I'm going to start out with a lesson learned. Every little problem that you have is a lesson to be learned, and I learned an important lesson, and that is, as the title says, more power, not always more gooder. I'm thinking that the problem was related to this. I cranked up the current on the drivers, thinking that the more power I pump into these motors, the faster that I can make them go, or the higher the speed I'll get out of them, kind of a thing. That didn't work out in the end in the first place, and I left them cranked up as it was, and I think that was working against me. I don't know the theory behind it. I think it's something related to residual magnetism in the stepper motors. The more current you pump into them, the more residual magnetism, and the harder it is for it to move to the next step. But I would have to look that up, and I wouldn't take my word for it on that one. I'm not sure. But basically, here's the deal. I played around with tuning on the stepper motors, and I'm finding that I'm getting much smoother sounding movement. Remember I said that it sounded noisier the other day? And some of that was, well, the first thing I was thinking was, last night I woke up and I was thinking about this stupid thing. And I thought to myself, I wonder if, remember the other day I said at the beginning of the movement it sounded weird, and I wonder if I was losing steps at the beginning. That thought is still in my head. That's why I'm going to do some measurement tests today. But the other thing I said was it sounded different. And that is probably a very significant thing, because I'm going to pause you guys and I'm going to show you guys a quick little test here. And you'll probably be able to hear the difference in the motors as I crank the current up. Okay, so what I'm going to do is I'm going to start out with my axes, X, Y, and Z. Z is this axis, X is this axis, and Y is the axis in that direction, back and forth. I'm going to do some tests on the X-axis, and I'm 100% sure you're going to be able to hear the difference. I'm going to start out with, I'm going to turn the current right down to the point where it won't actually be enough to operate the stepper motors. We'll do a 4-inch seek, and then I'll adjust it and I'll tune it up gradually, and you'll hear when it kicks in, or you'll be able to see when it kicks in, but you also should be able to hear the point where it actually starts to make some noise. And I think that's what the problem is that I'm cranking the current up too much, and it's actually causing me problems because of that. Somebody did actually say in one video or in one article I read online that more power is actually, or too much power is actually as bad as not enough power. And now I actually think I see what they're talking about. So let's go and I'll show you what I'm talking about. So you can hear it doesn't sound too happy there. Got nice and quiet. And that's full power. There you could hear that was quite noisy and it was full power. So we'll tune it. We'll do another 4-inch seek. And we'll turn it down a bit. And you can hear right about there the humming pretty much disappears right in that range. And I think that's what the problem was. I had too much power going in, and it was working against me in the end. So what I'm going to do is I'm going to re-zero the whole setup here and run the drilling program again, and we'll see how that goes. Now it turns out that I made a mistake anyways. I used a piece of 3/4 inch thick stock when I meant to use a piece of 1/2 inch stock, so this whole piece is, you know, rubbish anyways, but it'll be a good test for the drilling program here. So I'll pause you guys and I'll let you know how that goes. Okay, it's done. I nearly had a Scooby-Doo moment when it did all the holes in the same place up to here. Then you'll see what it did is it drilled them a little more than 1/4 of an inch south of there. Everything looks like it's in about the right position now. You just have to ignore the upper set of drill holes. All of them came in where I'd expect them to. There is a slight misalignment here, and I suspect that's because I didn't quite get my 0 point right. We'll see how we go. You know, I don't think it lost any more steps because it appears to be perfectly lined up with that dot that's underneath there when it came back. Certainly not off by very, very much. I don't see a visible difference. So, I think that we had two problems here. Problem one is I had my current cranked up too high. You know, more power, not more gooder. And I also think that there was a bit of tightness in the lead screw at this end because I'd never pushed this thing to its limits, like right to edge on the x-axis. I have on the Z, on the Y, but not on the Z, or sorry, not on the X. And I think there's probably been a bit of an accumulation of stuff here, so I'm going to run this back and forth a couple more times. And since this is a piece of scrap stock anyways, I'm kind of tempted to run my program, my routing program anyways, and see if there's any faults in it. And even though, you know, like the board will be useless after that, because it's too thick and it won't be cutting to the full 3/4 inch depth. It was only, the program was only for a 1/2 inch. But in any case, I'm gonna run that program, I think, anyways, see if I have any other problems, and then I'll cut a 1/2 inch piece of stock and we'll run it again, and I'll show you the results of that. There you go. Looks like it cut perfectly, you know, except for the fact that some dummy went and used the wrong thickness of stock. But nonetheless, you know, it just needs a little bit of, you know, sand and cleanup to clean up some of those holes. Obviously, there's the extra holes as well that are just a bit messy. I thought I had a brilliant idea about how to save this and use it. And the thought was to change the 0 point to 1/4 inch below the level of the material, which would cause it to cut all the way through the stock. But what's not so brilliant about that is the fact that when it's not cutting and it's traversing the board, it lifts up to a safe height, and that safe height is set to 1/8 of an inch, which would be still 1/8 of an inch below the surface of the material. I'm still going to try it, but I'm going to go through the file and I'm going to edit it to make the safe height 3/8 of an inch high. And we'll see how we go. I still think I can make this work. Anyways, guys, I'm pretty happy. I think I've figured out what my problem is. So, since this is probably going to end up being scrap stock anyways, I figure I'm going to do another thing. Well, after I edit all the way through the routing file for this, I'm also going to increase the speed. I'm going to change the speed to twice as fast as what it was doing before. I'm going to see how well it cuts. And if it blows up, then there's no great loss. I've already got a piece of stock cut to, you know, with the correct thickness. And if this one fails, I'll cut it again with the right thickness of stock and the original routing file. Anyways, I'll show you the results of this. Well, there you go, guys. Assembled. Pretty much ready to go. A couple of things. First of all, I did have to route it out. Like I said that in the previous segment. A couple of dings there from my missed attempt to do it right. One difficult part about using these furniture assembly screws instead of the usual fixture that those guys will do is that you have to drill into the frame that way. And you know, there's some inaccuracy here, but I think actually some of that is an error in the drawing. I think when I did the drawing, you see that gap at the bottom there. I don't think I took that into account when I did this piece here. And this piece is much, much higher up, and that's just plain bad drilling job on this thing. It's actually sitting a fair bit higher. But nonetheless, it seems nice and rigid. ready to go. I already tried these pieces in the frame. I was just going to use some wood screws to hold it in there. And it seems nice and, well, all the holes are correct. The only issue is with these ones here. This one is very close to that bolt, and this one actually is interfering with that bolt. So I'll have to either get some smaller headed bolts or grind a little bit of the plastic away. And to be honest with you, I'd rather not weaken the plastic, so I'll probably just, you know, knock the heads of the bolts down a little bit in diameter and call it good enough, because I can always replace them. These are a little bit harder to replace, at least at this moment. Anyways, guys, that's it. Got it all going here. Now, one mistake I made with these things is I forgot to increase the size of the slot to 10 millimeter. It's still 8 millimeter, but I'll just route it out on the milling machine. I can actually do that fairly easily, and I'll update the drawings. Otherwise, I think it's okay. The machine seems to be working good now. You know, if I work within the limits, like I don't try to make it speed too fast, it seems to work pretty good. So I'm really happy with this thing now. It's ready to go with the new hardware here. I just have to put a proper case together so that all this stuff is in one big box, and set that up so it's got good ventilation, all that sort of stuff. And it does go to show you that I shouldn't blame the software when it was a configuration problem on my part. So there you go. Simple solution. Just a question of tuning the motors to the drivers there, and everything worked great. Anyways, guys, thanks a lot for watching, and I'm gonna probably start on assembling this thing, you know, in the next little while. I don't have any of the electronics, but I think I have all of the hardware. I still have to make the bed for it. I wasn't going to make that out of MDF. I got to see if that'll be the first trial of routing aluminum, and we'll see how that goes. You know, I don't know which way that's going to go, but I'll try it and we'll see what happens. Anyways, guys, thanks for watching.